Kotliners. I'm Yev Kanivets, and today I will be talking about backend for mobile engineers with Kotlin and Ktor. So, in first place, I'm a mobile engineer. I'm not backend engineer. I have about 7 years of experience with Android and about 3 years with iOS. So, as many of you, I have a few pet projects, and one of them is emoji books, which allows to add my favorite book with some emoji, title and author, then update book, see the list of books and delete book if I don't like it anymore. And for many applications before, and for this one, I was asking myself the same question. Should I write my own backend for this mobile application or should I use Firebase? Are there any better options at the moment? In this talk, we will try to answer that question. So first of all, I was tired of Firebase and I decided to write my own backend. But as I googled something like 10 best frameworks for backend development, I found this 10. So the first one is Spring, which is huge framework for enterprise projects. I guess you should write code in Java. You have also Node.js, which is quite popular, and you write in JavaScript. You have Laravel in PHP, I guess, Django for Python, Rails for Ruby, Play for Go, Flask for PHP probably, ASP.NET you can write with C#, Cake PHP and Symfony are in PHP as well. The only common thing between them, from my knowledge, is that I don't know the primary language in which I should write for them. So I was a bit disappointed, but then I found Ktor. And Ktor is an asynchronous framework for backend development. It's fun, free, and open source once again. It allows you to create microservices, web applications, and much more. So it has official site, Ktor.io. If you go there, we see 4 main characteristics of Ktor. The first one is that Ktor is lightweight. So you use what you need, and Ktor allows you to transparently configure only the functionality your project requires. No magic involved, as with many frameworks. Then it's extensible, so you extend what you need with a configurable pipeline, about which we'll talk a little bit later. You can create the extensions you need and place them anywhere you want. It's multi-platform. Probably some of you already seen Ktor on mobile site as networking library, but it has 2 flavors, for backend and for frontend. And since it's written in Kotlin and can be compiled to jar file, you can deploy Ktor application anywhere where JVM is supported. Then it's asynchronous, so it scales as you need it. Using Kotlin coroutines, Ktor is truly asynchronous and highly scalable. Use the power of non-blocking development without the callback nightmare. And some of you already seen it on Android side, and on backend side it's even more pretty, up to me. Wait, is it written in Kotlin? Say nothing more. This was my first reaction, because it's backend framework, the real one, and it's already using Kotlin. It's written in Kotlin. I can write it in Kotlin. It has the same set of extensions, tools, features, which I already use in Kotlin multi-platform, Android development. So this is great. Let's do it. I go to download section and I see three options. The first one is generate Ktor project, which allows to generate a template online, and then download the project and just open it in IntelliJ IDEA. Plugin for IntelliJ IDEA, which you can install directly in your IDEA and generate project there. It's exactly the same stuff. And you can, of course, configure the project yourself by including plugins and dependencies right to your Gradle project. And the current version is 1.5.2. Probably something will change when you are watching to it later. So we choose the first option by going to start.ktor.io. And here you see a screenshot of Ktor project generator, where you can choose if you use Kotlin DSL or Groovy for build Gradle files. Then you choose engine, which is native by default. Ktor version, you write group, which is similar to application ID on Android. You choose name of the project and current version. Then you have a server tab with all supported features, which you can include in your template. I've chosen call login to see all the requests in terminal when the server is running. We have default headers to attach headers to all the requests. Status pages help us to handle exceptions on server side and then return some predefined responses to our clients. Routine feature allows us to declare endpoints. REST API for our clients. Authentication allows to authenticate users, and content negotiation is here to parse JSON back and forth. And with all these features selected, if you click build button, you have a zip archive downloaded to your PC, and then you see this structure, which is super similar to mobile projects. You have build Gradle in KTS, you have Gradle files, you have resources for some static stuff, you have settings, sources with just application KT in it, and folder for tests. Let's see how it looks in IntelliJ. First of all, these are all features available in the template. So you have dependencies for server-side templating of HTML, CSS, and some other libraries. So you can write some HTML pages and return them from your Ktor backend. You have different features available, almost for everything you need, as well as different authentication mechanisms for basic with email password, with digest, with JSON web tokens, with OAuth for third-party logins like Google, Facebook, so on. For content negotiation, you have JSON, you have Jackson, and you have content negotiation, which is Kotlin X serialization library. And even sockets are here. And now we go to IntelliJ project. Just open and choose the folder or build Gradle file. And here we see the main source file of template. This is kind of a mix of application and Android manifest from Android world. So main function is entry point, which redirects handling to engine main, native engine main, on which our application will be running. Then we have module, which is kind of entry point for our application, for our code. And here it's a function, And in this function, we have DSL for installing different features. The first feature is authentication, which is not configured at the moment. Then we have call login feature, which prints everything, like all the calls and other stuff in terminal. We have default headers, which add Xengine Ktor header to all responses. We have content negotiation for handling JSON or other format of Python data between server and clients. Status pages help us to handle different exceptions. For now, we have just two. It's authentication and authorization exceptions declared right here. And routing is, I would say, the most important one, which has one endpoint declared. So if we run application and go to web browser and type localhost, we will see hello world as the response. This is great. Then we have application test, which demonstrates how easily we can test our application with unit tests. Application conf helps us to configure some metadata like port, which is by default 8080, and this syntax allows us to pass port from environment variable, which will be useful when we go to production. And then in application we have modules, which is array, and this is actually what allows us to declare different modules, kind of microservices, and we can have many of them. But for this application, we will have just one module. And now you are looking on build Gradle KTS, which again similar to what we have on Android. We have plugins applied. Application plugin, it stands for Ktor application. Then we have Kotlin JVM plugin, which is needed to run our server on JVM. Group is kind of application ID. Application main class name says entry point, configuration of entry point, which is server-native engine main. Repositories from which we will be taking our dependencies, and in dependency block we have all the dependencies we need for this template. So this is Kotlin starter library. This is Ktor server native for our engine, logback for logging all the stuff. Ktor server core is kind of the only thing which is needed for Ktor application itself. Then EUS for authentication, and server host common, I'm not sure for which reason it's here, and server test is obviously for testing purposes. Let's go next. So you're probably interested in the architecture of Ktor, and it doesn't force any architecture on you aside of this application call architecture, which is architecture of Ktor itself. So every call which happens in Ktor has 5 predefined phases: setup, monitoring, features, call, fallback. They go one by other, and you can actually attach any phase before or after any of existing phases. So you can plug your feature here or here or here, and it will work. But most of the features will be plugged in features phase. Because Ktor doesn't force architecture on you and on me, for my emoji books backend, I've chosen MVC-like clean architecture, which is highly inspired by my mobile experience. So on the top you have API, REST API, which will be used by clients, mobile clients and web clients. it's kind of view or UI. If we're comparing to mobile apps, then API is divided to controllers. Each controller can work with several interactors. Each interactor can use repositories. Then repository uses external APIs or data access objects. And then data access objects are using database directly. Okay, just to refresh the idea of this talk, we are going to develop a backend for Emoji Books mobile application. This mobile application displays the list of books. We can add book, update book, or delete book. So basically we need 4 endpoints in our REST API. And in following about 60 slides, we will be going through the process needed to implement those endpoints. Let's start. First of all, we want to speak somehow between server and client. So we add serialization plugin, which acquires Ktor serialization dependency, which is Kotlin X serialization. If we are talking about Kotlin multi-platform, exactly the same stuff. Then to actually use it, we need to configure content negotiation feature with JSON, and we extract our books API to books and then add it to routing block on the bottom. Yes, and all the changes I'm doing in every step you can see as blocks on the left side of editor. So we need some entity for representing book. It will be data class book. We mark it serializable, so it can be transformed from and to JSON. It has 4 fields: ID, emoji, title, and author. And because we don't want our clients to set IDs, because otherwise they can clash. And so we need book body to accept data from our clients, and then on server side we generate ID, like unique ID, and handle it on our side, and also return to our clients, so they know like which of existing books have which ID. This is how our books API actually looks. This is extension function on root, which takes pass books. It will be prefix for all endpoints in this root. Then we have a mutable list of books, which will be used for storing books at the moment. And then we have 4 endpoints: get, post, put, and delete. Get simply returns our books. Post takes book body from call, generate ID for it, and add it to list of books and return books again updated. Put is for updating existing book, so it takes ID as pass parameter, parses book body without ID, and replaces in our list, and returns updated books, of course. And delete just takes pass param ID and removes the book with this ID from the list. If you are developing backend, even if you're a mobile engineer, testing the backend with a mobile application will be quite complicated. It just will take more time, and there are better tools for testing endpoints which you create. And one of these tools which we'll be using today is Postman. So it allows you to create REST requests and work with them easily. So here you can see add book request, which is post request. It has URL localhost 8080 with books prefix in path, and then as body we pass JSON, which is book body, and when we click send, we have our book added with ID generated on backend. So it's already working. Let's add another book, Rich Dad Poor Dad of Robert Kiyosaki, and hit send. And now we have 2 books. Let's check that get books request is working as well. So the only difference is changing post to get. We click send, and we have the same 2 books with same IDs returned by backend. So it seems to be working. That's great. Now we just want to update emoji for Rich Dad Poor Dad. We use ID of book we want to update, and we pass updated book body. So the only update is emoji. We click send, and we have emoji updated. So all 4 our endpoints are working like a charm. And now for some reason we want to delete book iRobot by Asimov. We pass book ID as pass param, and we see that book has been deleted. Wait, we wanted this architecture, but did we just put all the logic in API? Yes and no, because Books API is actually kind of controller, because it's working only with books. If you had authors, it would be another, like authors API and separate controller. So we have API and controller. But yes, all the logic is located here, like all the stuff. And we want to extract more layers to have a proper architecture. So let's do that. First, we extract books repository, which has the same list of books and methods get all, insert, update, and delete for working with that list. And later we can change list to something else. To work with books repository, our books API needs following changes. First of all, we pass books repository as dependency, as argument to books function, which is books API. And then we redirect all the calls to books repository. So for example, for getting books, we write books repository get all, which returns the same list of books as previously, but through books repository. The same for inserting, updating, and deleting book. Now we have API, controller, and repository levels. But what about interactors, which should be between them? In interactors, we put business logic. That's kind of use cases. The approach is following. For each endpoint, we are going to have at least one interactor, because endpoints are quite well separated from each other. So each of them should have some kind of business logic, and that business logic is located in interactor. Again, we are passing all interactors as dependencies, as arguments to books function, and then we use them. So this is extension respond books, which we will talk about a little bit later. But for example, for adding new book, we again getting book body from call, then constructing add book interactor request, passing book there, executing our interactor, and then depending on response, it can be success or failure, we respond with updated list of books or with bad request. And we apply the same approach for other endpoints. And here you can see respond books extension, which simply takes get books interactor as param and do the call and respond on call, on application call, with OK and list of books if everything is OK, and bad request if something went wrong. And it won't work if we pass book repository, like new books repository, to each of our interactors, because each repository has its own list of books, and we will be just working with different list of books instead of one. This is not what we want. Here's an example of get books interactor. It has response with success and failure, and in execute we just get books from books repository and return that in success. You can say that here is a lot of boilerplate code. We need just this actually, but with any architecture which you apply, you always write more code, but structure of your code becomes more predictable, more scalable, and more readable. And in many cases, this approach will be better than just using repositories directly. For example, here with add book interactor, we have request which takes book body, and with book body we get it, we generate ID, which is kind of business logic, so it's not just boilerplate now, and that book is inserted in book repository and we return success. So yeah, in all interactors right now we return success, so there is no failure possible, but this is for simplicity reasons. And in real applications you would like to have some validation of books, some some symbols which should be ignored, so on. So you would have failure for sure. This is update book interactor, which takes books, book ID and book body, and do the same stuff as before, and delete book interactor, which is quite straightforward. Right. Is books API user agnostic? Yes, it is. I mean, we don't have user ID or any other user-related stuff in our backend at the moment. So all the books are stored as a single list for all users. And if you add book, I add book, we have two books in our applications, and this is probably not what users would expect. Let's fix it. First of all, let's make difference between authentication and authorization. Authentication is action when a user confirms that they are users which they claim to be. So it's done by email password or some kind of token usually. And then once you know who users are, you can give them some permissions to access resources or do some actions. For example, in our case, it will be rules like users should be able to access his books, but shouldn't be able to change anything about and even see books of other users. Firebase Ktor has authentication feature, Actually, there are many already implemented authentications on Firebase, but you still need to write like sign in, sign up, restore password, and all other stuff. For that, you need to implement all the auth flow yourself. I actually tried it, and it took me a few days, and finally there were many edge cases which would take me a few more days. And fortunately, Firebase, yes, old good Firebase, has it's using GWT, JSON Web Tokens, for authentication, and it gives you on client side and on backend side access to those tokens, and you can use the tokens with your own backend. Let's see how it can be done. So we need Firebase somehow. This is admin SDK for server side. Then we have our updated authentication feature, which takes Firebase authentication, and then from credential, and we're talking about a little bit later, it generates Firebase principal, which has user ID, and the user ID is the only thing which we need right now. So we can distinguish books, all books by that user ID, and then we protect our books root with Firebase authentication. Let's check if it works. So we go to Postman, we have our GET request, we click send, and we have 401 unauthorized response, which means that the root is actually protected, and we need somehow to access it now. Let's go to implementation. Firebase admin dependency is needed to handle authentication server side. To init Firebase admin SDK, you need to generate a private key in Firebase project, which you of course need to create. And when you download the file, you put it in resources folder, and then access like this, pass it to Google credentials, and initialize Firebase app with it. Firebase authentication isn't supported by Ktor by default, so someone has implemented it for you. This is a GitHub repository. Unfortunately, it was updated about 10 months ago, and Kotlin version is outdated. So what I recommend you is going to library folder and just copying single source file, which is located there. It looks like this, Firebase auth. This is actually extension of that application call which we were speaking about previously, and it allows to intercept all the calls and insert authentication. Firebase credential is used here, it inherits from credential from Ktor auth, and it has inside token, which is Firebase token. It has user ID and a lot of other stuff inside, and this Firebase authentication provider gets that Firebase credential for you, and then you can generate Firebase principal. So Firebase credential is responsible for authentication, and Firebase principal for authorization. It has user ID inside. You should be using for requests. And the only problem with Firebase authentication is that it uses GWT token, which expires every hour. And if you're just using those tokens in Postman, you will need to get them every hour. It will be painful. So we add some constant test token, which is just like any string, any constant string, and then it corresponds to some test user ID. And we go to Postman again. We go to our emoji books collection, which is list of our requests: get books, add book, update book, and delete book. And it has authorization feature, which is applied to all our endpoints. We choose beer token authorization and put our constant token for testing in Postman in token field. Now we go to get books request, hit send, and now we can see list of books. It means that we authenticated successfully. Great. Now let's see which updates we need in our books API. You can get user ID from call.principal Firebase principal. So we get Firebase principal, and from that we get user ID. This we do for all requests, and then pass that user ID to all interactors. In interactors, we just pass it to books repository. And in book repository, the changes we do is books becomes not mutable list, but map of strings to mutable lists. So for each user now we have its own list of books. And then for each operation, we get user books, which is list as previously, and do the same operation as before. Wait, is all data erased on server relaunch? Yes, it is, because our books are right now stored in operational memory, and on every relaunch, it's obviously erased. That's not what users would expect from application with Backend. They need to be persisted between launches, and for this we will be using database. Ktor has a great stack for databases. So on the top of stack we have exposed library, officially supported by JetBrains. It's kind of a wrapper for relational databases. It can be used with Postgres, which we'll be using in our app. It can be used with MySQL and other popular relational databases. And Hikari is kind of connector driver between our application and real database management application. But database is a separate stuff, like thing, which we need to create. First, we need to install PSQL command line application. Then we log in with Postgres default admin account. We create another user for our application, emoji books, with some password. We give access to emoji books to create database. Then we relog in with emoji books user and create database emoji books. All the coordinates of our local database is written as GDBC URL, which has address of local database like server, name of database, name of user, password for that user, and that's it. For init in database, we need to connect database to database through Hikari. Then we need create a table if needed, books DAO. You'll see it in a few moments. And Ktor itself takes environment variable in the first place, and if it doesn't exist, so it's kind of not prod application, we take our default JDBC URL, which points to local database. Books DAO, it's object which is created from table from exposed. It has name books and 5 fields. All of them are text, but there are many different types of fields available in exposed. It has ID, user ID, emoji, title, and author. And now we can update our books repository to actually work with DAO, which works with database. Books DAO gives us a lot of ready-to-use functions. For example, for getting books, we write books.dao.select, and then we declare how we should select books from our database, and then we map result to actual book entity which we have, data class. And DAO is based on the concept of result row, which is very similar to Ktor on Android. It's kind of map. And we have operation for update, for delete, and mapping here. Backend is ready now. How to host it? Because if you want other people to use your application, your backend, not in your apartment, you need to host it somewhere. But first, have to ship your backend to hosting. The easiest option, and probably the only one, I don't know, but I know only about this one, is to packaging your backend application as jar file, like fat jar, so it has all dependencies and all your code inside, and it can be run on any Java virtual machine with command java -jar and name of your jar file. We are using shadow jar for this. And now once we have a jar file, we need to choose hosting. For hosting, I suggest Heroku because it has a free plan which is sufficient for our needs, and it's also like very simple in deployment, in configuration, and so on. So here you see app.json, which is needed for configuring application on Heroku. Then we need to install Heroku CLI. We create application with it. Here we have Git link, which is already added to your Git. So if you use, like, you have new origin, which is called new remote, which is called Heroku, and URL for your backend application. Then you add Gradle task shadow jar, so it knows which command to execute to build the application. And you do git push Heroku master, and you can see logs of how your application is building on Heroku. And the most important thing is that build is successful in about 2 minutes. And then if you use this link, you will get crashes, like your server even won't start because you don't have a database on backend. Like, you have a local database, but it obviously can be used by real production backend. But Heroku has a free database solution for you as well. So you go to dashboard Heroku.com, you click configure add-ons, and search for Heroku Postgres. Choose Hobby Dev free plan. It has about 10,000 records for free, which is enough for our app, and it will be like used automatically thanks to our JDBC URL environment variable. And now if you change localhost to Heroku URL and click send, you have a list of books with 200 OK response status. So our backend is working right now. What's next? If you still remember, our goal is to develop backend for mobile application. And if you developed backend for mobile application, we want to integrate it to see if it's actually working. For initial goal will be minimalistic. So we add splash activity, which using Firebase AUS, sign-ins with predefined email and password. I've just created user in Firebase developer console. Once user is created, we get ID token for it, which is JWT token. And once we have token, we will use it for, we will add it to every request to our backend. This is how a book repository will look like in mobile application. So we create HTTP client, which is Ktor HTTP client, and then using HTTP client we can get books, list of books. On pass books we can add book, which is done by post request with body equal to book. We can update book by passing ID and book body, and we can delete book if needed. And here's just some mapping. This is how HTTP client factory looks. It takes a token and then creates a default request, which consists of host. This is our backend link, protocol, HTTPS obviously, but locally, by the way, it will be HTTP. It has authorization header, which is very important, otherwise our actions won't be authorized. And content type header is needed to say to our backend that we are going to use JSON for sending and receiving data. And that's actually it. So our mobile application is ready. It's open source. You can see it by visiting my GitHub profile by this link. Backend is ready as well. So it can be accessed on GitHub too. This talk is based on 2 articles of mine on Medium. First one is Backend for Mobile Engineers with Kotlin 8 and Ktor. It explains the same process on example of different application, which is real-world application with about 4,000 users. And Firebase AUS with Ktor backend for Firebase AUS part. A few other links which can be useful if you want to go a little bit further. The first one is all of them are YouTube videos. The first one is Ktor from the ground up by Anton Archipov from JetBrains and actually from Kotlin team. Ktor past, present and future by Hadi Hariri, again from JetBrains and from Ktor team, I guess. And the third one is Come to the Backend side, we have Kotlin by Julien Salvi. That's it. Thank you for your attention. Thanks for attending the talk. Let's go to questions.